University, led by Professor Dr. Walid Taufik, a team of physicists has developed a revolutionary tool to fight pollution. Traditional methods are slow and complex, but this innovation changes everything.
What's up, Professor Walid Taufik? He's the professor of laser spectroscopy and ultrafast lasers, and heads the Department of Laser Applications in Metrology, Photochemistry, and Agriculture at Niles, Cairo University. His team developed a way to spot pollutants in real time with just a zap of picosecond laser pulses. Imagine scanning for dangerous chemicals in the air or soil on the spot. No chemicals are waiting around. That's huge for farms, cities, everywhere. Next, Associate Professor Mohammed Fikri from Cairo University's Ultrafast Picosecond Laser Lab made sure the system is ultra-precise and portable. He fine-tuned the lasers for real-world conditions, so scientists can literally take this setup to the field. And Professor Manal Mubarak from Ain Shams University's Soil and Water Department, she tested how this tech helps farmers and researchers see, live, how pollution is affecting soil and crops. Now farmers can protect their land and our food better than ever before. Finally, researcher Mohammed El Saeed at Niles took this tech out of the lab and into the field, making sure it works in tough Egyptian environments. This isn't just science for science's sake. It's science making a real difference right now.
Near Cairo, the Abu Zabal industrial complex has fueled Egypt's growth for decades, but at a hidden cost. The soil around this hub is now laced with toxic heavy metals, silent remnants of industry. These contaminants seep into crops and livestock, entering the food chain and threatening human health. For local farmers, the land has become an invisible enemy. Traditional soil testing is slow and cumbersome, delaying action against this threat. We needed a faster, clearer way to reveal the soil's secrets. Enter a team of Egyptian scientists determined to protect their homeland. Their solution? Harnessing the power of lasers to analyze soil instantly. This innovation marks a turning point in the fight against pollution. It's a story of science illuminating a path toward a safer future. The poisoned earth of Abu Zabal is no longer hidden in darkness. With new technology, hope for recovery is finally within reach. Egyptian scientists introduced ultrafast picosecond laser-induced plasma spectroscopy, CFP's LIPS. This technique uses a laser pulse lasting just a trillionth of a second to vaporize a speck of soil. The resulting plasma emits light, revealing the soil's elemental makeup. Each element leaves a unique spectral fingerprint instantly identified by a spectrometer. No chemicals, no waiting, just immediate answers. Thousands of laser shots create a detailed chemical map in minutes. What once took days in a lab now happens almost instantly. CFP's LIPS gives us a real-time snapshot of soil health. It's a leap forward, letting us see and respond to contamination as never before. With this laser, the invisible becomes visible. Science now speaks the language of the earth clearly and quickly. Armed with laser technology, scientists mapped heavy metal contamination around Abu Zabal. Their data revealed alarming levels of cadmium, zinc, iron, and nickel, far above safe limits. These maps pinpoint pollution hotspots, guiding targeted cleanup efforts. Instead of treating vast areas blindly, authorities can focus on the most dangerous zones. The technique also allows ongoing monitoring, tracking progress as remediation unfolds. It's a cycle: measure, act, verify, ensuring real results. The laser is now a guardian, helping heal the land and protect communities. Science turns data into action, making environmental recovery possible. Compared to old methods like atomic absorption spectroscopy, the laser technique is a game changer. Traditional tests require hazardous chemicals and days of lab work. The laser method analyzes solid soil directly. No prep, no delays. Results are fast, accurate, and reliable, matching the gold standard. Its portability means scientists can test soil on-site, making real-time decisions. Environmental monitoring shifts from reactive to proactive. Agencies can now respond to pollution with unprecedented speed and precision. This is a paradigm shift in how we protect our environment. The future of soil analysis is here, and it's powered by light. Science is now faster, safer, and more effective than ever. The Egyptian team's breakthrough is more than science, it's hope in action. Their laser technique arms the world with a powerful tool against pollution. Local innovation now has global impact, offering solutions for contaminated lands everywhere. Science, rooted in community, can change the world. With this technology, we can hold polluters accountable and design smarter cleanups. The journey from poisoned soil to recovery is now possible. This is a reminder. With knowledge and determination, we can heal our planet. The light of a laser, guided by human curiosity, shows us the way forward. A cleaner, safer future is within our grasp. In the story of human discovery, Egypt has always shone bright, a cradle of civilization, a land of innovation. Today, a new generation of Egyptian scientists is exploring not the stars, but the world of atoms and molecules. Their tool, the laser, an instrument of extraordinary power and precision. This is a story of science, of protecting our world, and of carrying the torch of discovery into the 21st century. Our connection to the earth is vital. The soil, water, and air sustain us, but modern industry can threaten this balance. Invisible dangers like heavy metals seep into our environment, posing silent risks. Science gives us the tools to detect these threats and find solutions. In Egypt, researchers are using lasers to reveal what's hidden, safeguarding public health and natural heritage. Imagine wielding a beam of light so powerful, it uncovers the secrets of matter. This is the reality of modern physics. Lasers have revolutionized fields from communication to surgery, and now, environmental science. Egyptian scientists are harnessing this technology to protect their land and people. Their work connects ancient wisdom with future promise. From the Nile Delta to advanced labs, this is a journey of curiosity and relentless pursuit of knowledge. A focused beam of light becomes a detective, uncovering clues once invisible. We'll meet the scientists leading this charge, their discoveries echoing far beyond Egypt. The health of our planet is a shared responsibility. The quest for knowledge knows no borders, and the light of discovery continues to guide us all. Let's dive into the heart of matter, where everything is made of atoms, each with a unique fingerprint. To see this fingerprint, you excite the atom, and it emits light in colors unique to each element. This is the principle of spectroscopy, the same method we use to analyze distant stars. Laser-induced plasma spectroscopy, or LIPS, brings this power to Earth. Scientists fire a focused laser pulse at a sample, soil, water, or food, creating a tiny superheated plasma. This plasma, like a miniature star, emits light as it cools. Each element in the sample produces its own spectral signature, a barcode of light. Special detectors capture and separate this light, revealing exactly which elements are present and in what amounts. LIPS is fast, versatile, and requires little to no sample preparation. It works on solids, liquids, and gases, and can be used in the field or the lab. You can analyze artifacts without damage or test soil on the spot. It's a universal chemical sensor providing answers in minutes. This technology opens a clear window into the chemical world around us. It empowers us to ask new questions and get rapid answers. LIPS is revolutionizing how we understand and protect our environment. It's a tool for discovery, safety, and progress. With LIPS, science becomes immediate and accessible. The secrets of matter are now within our reach, and with every pulse of light we see our world more clearly. The future of analysis is here. How does this technology impact our daily lives? Let's start with the soil beneath our feet. Contaminated soil can pass toxic metals like lead and mercury into our food chain. In Egypt, LIPS helps researchers rapidly scan farmland, mapping contamination and protecting crops and health. The journey of pollutants continues into our food. In Saudi Arabia, LIPS has been used to test dates for heavy metals, ensuring food safety without destroying samples. In medicine, LIPS verifies the composition of pharmaceuticals, confirming essential minerals and detecting impurities. This ensures our medicines are safe and effective. From farm to pharmacy, LIPS acts as a silent guardian. It reveals invisible threats in our environment and products. Fast, reliable data empowers better decisions for farmers, producers, and healthcare professionals. LIPS transforms fundamental science into practical solutions. It makes our world safer and healthier. Light, once again, protects our well-being. For decades, pollution testing relied on traditional methods like atomic absorption spectroscopy, AAS, and ICP-MS. These techniques require complex, time-consuming sample preparation and expensive lab-bound equipment. Each element often needs a separate run, making the process slow and inflexible. While powerful, these methods can't provide instant on-site results. Enter LIPS, a game-changer. With minimal or no sample prep, LIPS analyzes samples in their natural state. Scientists can point a laser at a rock, leaf, or tablet and get results in seconds. LIPS can detect multiple elements at once, offering a complete picture instantly. This speed and versatility allow rapid screening of many samples, impossible with older methods. However, early LIPS struggled with accuracy and sensitivity, affected by sample properties. Precise quantitative measurements were challenging. To truly revolutionize testing, LIPS needed to become not just faster but smarter and more accurate. The answer lay in the very nature of light. By refining the technology, scientists aimed to overcome these limitations. The next leap would change everything. Ultrafast lasers would unlock LIPS's full potential. The next breakthrough came with ultrafast lasers, pulses lasting trillionths or even quadrillionths of a second. These picosecond and femtosecond lasers deliver energy so quickly that the sample vaporizes cleanly, creating a stable plasma. This results in more consistent light emission and dramatically improved measurement accuracy. The real revolution: calibration-free LIPS, CF LIPS. Traditional methods require calibration with known samples, a slow, painstaking process. With ultrafast lasers, scientists can calculate concentrations directly from the light spectrum, no calibration needed. This makes LIPS truly field deployable, accurate, fast, and portable. Egyptian researchers at Cairo University's Niles combined picosecond lasers with CF LIPS to tackle real-world pollution. Their work became a landmark study. They brought advanced technology to environmental challenges in their own backyard. The result: instant, reliable analysis anywhere. This leap forward redefined what was possible. Science became more accessible and impactful. The power of light was now in the hands of those protecting our world. Ultra-fast lasers made LIPS a tool for the future, and Egypt was leading the way. In the Abu Zabal industrial zone near Cairo, concerns about pollution ran high. Scientists from Niles set out to investigate using their advanced picosecond CF LIPS system. They collected 50 soil samples from various locations and depths, building a 3D map of the area. No complex preparation was needed, just pressed soil pellets ready for analysis. Each laser pulse revealed the concentrations of nutrients and, crucially, toxic metals like lead, cadmium, chromium, and nickel. Results showed higher contamination near the industrial complex, decreasing with distance. The team innovated further by combining pollution data with wind patterns. Their geospatial map pinpointed the highest contamination downwind from the factory, tracing the pollution's path. They didn't just measure pollution, they mapped its journey. Their work provided clear visual evidence of industrial impact. This data empowered communities and policymakers to act. Science illuminated the hidden dangers, guiding solutions. The Abu Zabal study was more than research, it was science serving society. Detailed maps and data gave agencies and policymakers the evidence needed for targeted action. Solutions like better factory filters and soil remediation became possible. For local families and farmers, it meant a healthier environment and safer food. The study set a new standard for monitoring industrial zones worldwide. Egyptian scientists at Niles became leaders in advanced laser analysis. Their work inspired others and strengthened Egypt's scientific community. This research built trust between science and the public. It showed that science solves real-world problems and builds a safer, more sustainable world. A beam of light became a beacon for a healthier future. We face global challenges: climate change, pollution, new diseases, but also unprecedented opportunities. The story of laser spectroscopy in Egypt shows how science transforms discovery into practical solutions. From ancient astronomers to modern physicists, the quest for knowledge drives progress. Science is more than facts. It's a way of thinking, questioning, testing, and refining our understanding. In a world of misinformation, this mindset is essential. Investing in science is investing in our future. Centers like Niles empower minds to create solutions for their communities and the world. Discoveries lead to new industries, better healthcare, and a cleaner environment. The torch of science lights our path forward. From the light of distant stars to tiny stars in the lab, we learn to protect our planet. The journey of discovery continues with mysteries yet to solve. As long as we reach for the light, our potential is limitless. The future is ours to build, illuminated by science and human ingenuity. Welcome to For Science Salah Lotfi channel. In this episode, we take you to the western edge of Egypt's Nile Delta, to the agricultural fields surrounding Al-Kanka city, where scientific research is uncovering new insights into environmental contamination using advanced laser techniques. In the winter of 2022, a dedicated research team launched a soil sampling campaign in this region. Their focus? the area surrounding the Abu Zabal Industrial Complex, a facility known for its production of chemicals and fertilizers. The objective was clear: to assess the presence of contaminant elements in soils located near this industrial hub, and to do so with precision and scientific rigor. 6 soil samples were collected from a 2-square-kilometer area. The sampling followed a strategic pattern guided by both direction and distance. 2 main directions were chosen for the study, one facing north, labeled S1, and another to the south, labeled S2. From each of these directions, researchers collected samples at 3 distinct distances from a central reference point: 200 meters, 750 meters, and 2,000 meters, marked as P1, P2, and P3, respectively. This systematic design allowed for comprehensive spatial analysis, enabling the team to trace how industrial emissions might be dispersing into agricultural soils across varying distances and wind directions. After collection, the samples were transported to the lab, where each underwent careful preparation, dried, sieved, and labeled for analysis. But this was just the beginning. In the next step, these soil samples will be examined using a cutting-edge technique known as calibration-free picosecond laser-induced plasma spectroscopy, or CFPS-LIPS. This technology allows for direct, accurate detection of contaminants without the need for extensive chemical preparation. Stay with us as we continue to explore how laser technology is revolutionizing environmental monitoring in Egypt. This is For Science Salah Lotfi channel, bringing scientific insight closer to you.
What's really hiding in the soil beneath our feet? While healthy soil grows our food, it can also harbor dangerous pollutants. Heavy metals like lead, cadmium, and nickel, often from factories, can contaminate farmland, threatening crops, water, and our health. These metals linger for decades, making their way into our food and causing serious health risks. Egypt's ancient farmlands along the Nile now face modern threats from growing industry. Traditional soil testing is slow, often taking weeks, too long to prevent damage. Imagine if we could instantly detect these invisible threats right in the field. That's the promise of new laser-based technologies, offering hope for faster, more effective protection of our agricultural lands. Scientists are racing to develop these tools, aiming to safeguard both our food and the environment. The first step: finding and mapping the pollution before it spreads. Let's see how this new science is changing the game. Scientists targeted Al-Kanka city near Cairo, home to both fertile farmland and the massive Abu Zabal industrial complex. Factories here produce chemicals and fertilizers, but also release heavy metals into the environment. Decades of industrial activity made this the perfect place to study pollution's impact. Researchers mapped the area, focusing on how wind spreads contaminants from factories to farms. By understanding these patterns, they could pinpoint pollution hotspots and test new detection methods. This local study could shape pollution control strategies across Egypt and beyond. The team collected 25 soil samples from different directions and distances around the industrial complex, creating a detailed pollution map. Samples were taken from upwind and downwind locations, some close to factories, others kilometers away. Each sample was carefully prepared, dried, ground, and pressed into pellets for analysis. In the lab, scientists used 2 methods: the traditional atomic absorption spectroscopy, AAS, and a cutting-edge laser technique. AAS is accurate but slow, requiring complex preparation and days of analysis. The new laser method promised faster results, potentially transforming environmental monitoring. By comparing both methods, researchers aimed to prove the laser's reliability. The stage was set for a head-to-head test of old versus new technology. Would the laser be as accurate as the trusted standard? The answer could revolutionize how we protect our soil. Enter the laser calibration-free picosecond laser-induced plasma spectroscopy, or CFP's LIPS. A powerful, ultra-fast laser pulse vaporizes a tiny bit of soil, creating a glowing plasma. Each element in the soil emits a unique light signature, like a fingerprint, when turned into plasma. The instrument reads this light, instantly revealing which metals are present and in what amounts. Unlike traditional methods, CFP's LIPS doesn't need calibration standards, making it much faster. Picosecond lasers create cleaner, more stable plasma, boosting accuracy. Results appear in minutes, not weeks. A game changer for rapid pollution detection. This technology allows scientists to respond quickly to contamination threats. It's a leap forward in protecting our environment and food supply. The results were clear. Soil near the Abu Zabal complex had high levels of heavy metals, especially downwind of the factories. The pollution gradient pointed straight to the industrial source, confirming the role of wind in spreading contaminants. The new laser method matched the accuracy of traditional testing, but delivered results in minutes. This breakthrough gives Egypt, and the world, a powerful tool to monitor and manage soil pollution. Authorities can now map contamination, act quickly, and protect both farmland and communities. Science and technology are lighting the way to safer agriculture. With innovations like CFP's LIPS, we can ensure a healthier future for our food and our planet. Sometimes all it takes is a spark of ingenuity and a flash of laser light.
All right, let's talk about something truly exciting in the world of environmental science. Did you know that Egyptian researchers are shaking up how we monitor pollution? And it's getting global attention? Let me break down what's going on. A powerhouse team out of Cairo is using cutting-edge laser technology to detect and analyze environmental pollutants like never before. Imagine using lasers to sniff out toxic chemicals in our air, water, and soil. Live on the spot, no waiting for slow lab results. Sounds like science fiction, right? But it's happening right now. This isn't just any research. We're talking about professors and scientists from Cairo University and Ain Shams University. Heavy hitters in laser spectroscopy, soil and water science, and environmental physics. They've created a model that combines ultra-fast lasers with advanced sensing techniques to pinpoint pollution hotspots instantly. It's fast, accurate, and adaptable almost anywhere, whether you're in a busy city or out in the fields. And here's the kicker. Their work just got published in Scientific Reports, one of the world's top scientific journals. That's a big deal. It means their model isn't just good for Egypt. It could change the way countries everywhere tackle pollution, making a real difference in the fight for a cleaner planet. So, what does this mean for all of us? For starters, quicker detection means quicker action. Less time for pollutants to spread and more chances to protect the environment before damage is done. That's impact. If you're as fascinated by this as I am, check out the full paper. The link's in the description. And hey, drop your thoughts or questions in the comments because this is the kind of breakthrough that should get people talking. Thanks for tuning in. Like, share, and subscribe in for Science Salah Lotfi channel for more deep dives into the science that's shaping our future. I'll catch you in the next one. Hey science lovers, welcome back. Today I'm diving into one of the coolest advances in analytical chemistry, how scientists can now measure heavy metals like cadmium and zinc, the hassle of calibration. Yep, you heard right. No endless calibration curves, no tedious standards, just pure direct measurement thanks to plasma spectroscopy. So, what's the secret? It's called calibration-free, partially standardized laser-induced plasma spectroscopy. Let's just call it CFPS LIPS. Instead of constantly comparing your sample to known standards, this method skips straight to the science. It analyzes two things in the plasma: electron density and electron temperature. Imagine blasting your sample with a laser, turning a tiny spot into a hot plasma cloud. By looking at how wide a certain calcium spectral line gets, this is called stark broadening, scientists can figure out the number of electrons in that plasma. In one recent study, they nailed down the electron density to about 1.54 times 10 to the 17th per cubic centimeter. That's precise within just 3.5% error. Next, electron temperature. Using the Boltzmann plot method, basically, charting the brightness of different calcium lines at different wavelengths, they measured a plasma temperature of over 9,000 Kelvin. With these numbers, scientists plug them into equations for each metal and, bam, they've got the concentration right there. But does it work in the real world? They tested it on actual environmental samples, finding levels of cadmium, iron, zinc, and nickel. The results matched up almost perfectly with the gold standard ICP-OES technique, but without the need for any calibration. The difference? Less than 1% error? That's huge compared to the old ways. Plus, this approach can map out how both electron density and temperature change around pollution sources, giving deeper insight into contamination patterns. So, to wrap it up, CFPS LIPS is a game changer for environmental science. It means faster, more accurate detection of heavy metals right in the field without endless lab work.